Life on Earth didn't evolve to explore space. We know there's all sorts of issues with human physiology in space. Fluorescent Deep Space Petri-Pod aims to fly worms in space to disentangle the various effects of microgravity on biological organisms.
At the moment, there's a need within the space community to be able to do exposures, and we then came up with a generic platform that you could use for worms, but equally you could use it for other things. From a worm's perspective, that's almost like a little tiny space station for them. We are taking some of the simplest animals on Earth and training them to be little astronauts.
What the team's done here is engineer a 12-pod system, 4 with fluorescent microscopes and optical microscopes, another 8 for things which will just be exposed to the space environment. C. elegans worms, which are these 1 millimetre worms which you find everywhere on Earth, have got fluorescent organs in their head. So the idea is to take pictures both in visible light and then in fluorescent light to actually see these organs and see how well they're actually moving.
It's a complete package, a really good piece of science with data at the end of it, and nobody, as far as we're aware, has ever done automatic fluorescent microscopy outside of the International Space Station.
Once it gets to the ISS, it will sit there for at least 18 weeks before it's brought back in. When the FDSPP, as it's called, comes back to Earth, then we'll be able to download the data from the memory on board.
I think one of the visions that we always had was, once we've demonstrated the technology, start working with people from other universities, people from Europe as well, looking to see whether we can accommodate their experiments on a CubeSat, or even you could send it to the moon if you wanted to. And there's some of the other crazy ideas that we have for the future.